Thank you, David. Good evening, everybody. What a great lot of energy, and you're all still here. Well done, team. This is a great, great event. We are, as a species, sleepwalking into the future. And we're being led there by maybe 10,000 people who are running blindfold into the future. And it's not surprising that most people aren't thinking terribly hard about what lies ahead, because it's confusing. It's a very complicated picture. So I'm going to try over the next 20 minutes to lift some of the confusion. I'll give you some context, give you some thoughts about what is going to happen in the future, and then ask what should we be doing about it. Let's start with the definition. What is artificial intelligence? The artificial bit is easy. It's something created by humans, or possibly by aliens, but not by evolution or by God. The intelligence bit is trickier. Anything to do with the human brain is tricky, but there's a good four-word definition. Goal-directed, adaptive behavior. That's intelligence. So if an entity has got a goal and it learns and changes its behavior as it pursues it, that is intelligence. And the science of AI got started in 1956 at a conference in Dartmouth College. And right from the beginning, there were two types of AI. And it's easiest to think about them using Daniel Kahneman's model of fast and slow thinking. So neural nets are like system one. They're fast, they're not entirely reliable, but they're good for most situations. They're like intuition. And it did initially look like that was going to be the most successful type of AI. A man called Frank Rosenblatt invented perceptrons, and they were doing very well. Until 1969, a man called Marvin Minsky, another one of the founding fathers of AI, wrote a book called Perceptrons, which killed neural networks, pretty much stone dead. And that left the other type of AI, which is symbolic AI, sometimes known as good old-fashioned AI. And this is like our reasoning system, Daniel Kahneman's System 2, which is slow, it's much more reliable, and we're not very good at it. That was the type of AI which lasted from 1969 until quite recently. It did some impressive things. In 1997, a system called Deep Blue, built by IBM, beat probably the world's best ever human player of chess, Garry Kasparov. Kasparov was not very happy about this. He accused IBM of cheating, which was probably true. But despite doing some impressive things, this type of AI didn't make any money, and that is, after all, the acid test of a technology. And as a result, there were some AI winters in which AI researchers just couldn't get money for their research. And that stopped. Everything changed in 2012, when a computer scientist called Geoff Hinton, after 29 years of trying, got an algorithm called backpropagation to work and reintroduced neural networks. Remember System 1, intuition-like neural networks, and that introduced deep learning, which is a variant of and a rebranding of neural networks. And that, over the following decade, gave us some miracles. Google Maps. Some of you are old enough to remember when to go from A to B, you had to have a physical map on your lap, and it couldn't tell you how long you were going to take, and it couldn't redirect you if something went wrong. Now Google Maps and other maps are available, can do all that. And with Wikipedia and AI-powered search, we have something very close to omniscience. So these are miracles deployed by the big tech firms. No other companies really deployed these, but they've been absolutely tremendous, and mostly find them on your smartphone. So that was the first big bang in 2012, the arrival of deep learning. The second big bang was in 2017, when some Google researchers wrote a paper called All You Need Is Attention, riffing on the Beatles song, and that introduced a type of AI called transformers, which fortunately has nothing whatsoever to do with these guys. What transformers enabled was generative AI and large language models, which I'm sure we all use many times every day. There are still people who think that large language models are basically predictive texting, which we've been familiar with in our phones for years and years and years. Statistical analysis of sentences to figure out what comes next. They are much, much more than that. They build a model of language. They do what they say on the tin, large language models. They build a model of language, they work out connections, they work out relationships between all the words that they've ingested. They've ingested just about every word that there is. There's a number of things which have made all of this possible, and the big one is exponential growth. Also the arrival of NVIDIA chips, thanks to the video industry, and Fei-Fei Li's magnificent ImageNet database, which was necessary to trace the deep learning systems. But exponential growth is the big one. And as I'm sure you all know, it means that every 18 months or so, the power of compute doubles. And I'm sure you also know that if you walk 30 ordinary steps, you'll go about 30 meters. If you walked 30 exponential steps, you'd go to the moon. I'm sure you all know that. And while we're talking about the moon, to put this in context, when NASA sent Neil Armstrong and the others to the moon in 1969, the compute power they had was less than the smartphone in your pocket. I'm sure you've heard that. It's been true for a while. In fact, it's very out of date because now, today, the compute power of a good toaster is more than NASA had when they sent Neil Armstrong and the others to the moon. And I don't know about you, but what that says to me is that Neil Armstrong was incredibly brave, because I wouldn't go to the moon relying on the intelligence of a toaster. So that's how we've got to where we are. 2 big bangs, we've got large language models. What's going to happen next? What lies ahead in the future? There's a lot of money being spent on AI, as you know. A lot of it by the Magnificent Seven, some of them not quite so magnificent. Poor old swastikas down here, a lot less magnificent than it used to be. But they're still spending a great deal of money on AI research. To put it in context, Amazon, what Amazon spends on AI research is equal to what the UK spends, excuse me, what the UK spends on research, not just AI, but on everything. And I mean by that the UK's government, all its companies, all its universities. Amazon spends about the same amount. So these companies are spending a vast amount of money on AI. And in China, there's an awful lot of research going on. These are their traditional AI companies. Baidu is more or less their Google, Alibaba, their Amazon and Tencent, their Facebook. When Transformers came along, so when the second Big Bang happened in 2017, the Chinese AI firms looked like they were falling behind. It took them a while to catch up, but they caught up. So DeepSeek has shown that China can make large language models just as innovatively as the Americans can. And here is a list of all the great European tech giants, and indeed all the great African and South American and other Asian tech giants. That's maybe being a bit unfair to Spotify, but it's not really in the same category. Now, I think this is a problem, and actually in the last few months it's become even more of a problem. No disrespect to America or China, well, not much disrespect to them, but it's not a great idea for humanity's most powerful technology to be a duopoly between these two countries. Europe has expertise, some of it's in this room. Europe has money, and we need to have the ambition to join this endeavor. We should not leave it to be a duopoly. You will hear it said that Moore's law is dead or it's dying. It's not true. People have been saying this for a very long time, for a couple of decades at least. Moore's law has always changed, and it is changing now. Today it's more about algorithms than the physical chips, but it is extremely likely that we're going to continue to get the rapid growth of compute power that underpins the growth and the performance of AIs. And we're about due for a third Big Bang. We had one in 2012, another in 2017. Maybe the third one is going to be neurosymbolic AI. So remember there was neural networks, System 1, intuition, and symbolic AI like reason, System 2. People have been saying for a long time that we need to reconnect these two or bring them together, and that might be the third Big Bang. Now, if we do maintain the exponential growth in the performance of compute and the exponential growth in the performance of AI, then this is what happens. In 10 years' time, the machines we have will be 100 times more powerful than the ones we have now. In 20 years' time, 10,000 times more powerful, and in 30 years' time, 1,000,000 times more powerful. Imagine having a conversation with ChatGPT 4.0, but 1,000,000 times more powerful. It is hard to imagine what that will be like. We know that this is the year of AI agents. Everybody's been talking about this today, and it's completely true. This year, AIs are going to be able to interact with the real world, to do things in the real world, taking over your keyboard and booking flights and reconciling accounts, and doing quite complicated things with minimal human supervision. And David mentioned that I'm a co-founder of a company called Contium. One of the things that we're going to be doing is verifying that these agents do what they're supposed to do, because you do not want them going rogue and doing unexpected things. AI agents are going to accelerate a process which has been going on for a long time and which has been talked about for a long time, and is the first of the two big things I want to talk about that are going to happen in the future. So this is automation. And as I say, we've had automation for a very long time, since before the start of the Industrial Revolution. A great example is the agricultural industry, and it's a great example because until fairly recently, agriculture was most of industry. In 1800, 80% of all Americans who worked at all worked on farms. In 1900, that number went down to about 40%, and today it's between 1% and 2%. Now, the descendants of all those 1800 farm workers are not all unemployed. Automation did not render us all permanently unemployed. They are working in shops and offices and factories around the world, and they're in this room. Because when machines took our muscle jobs, and that's what they did, they mechanized our muscle work, we had something else to offer. We didn't just have our muscle power, we had our cognitive ability. So many of the descendants of those farm workers are now doing cognitive work. It didn't work out quite so well for the horse. In 1915, there were 22.5 million horses working in America, mostly pulling vehicles around. And today, the horse population of America is 2 million. So from 22.5 million to 2 million, I think you'll agree that is unbridled technological unemployment. And it turns out that 2015 was peak horse. When, you have to ask, when is peak human? Now, economists deny that this is going to happen. Economists say we will always work with computers. Why? Unless there's a silicon ceiling, some barrier beyond which AI, for some mystical reason or some quirk in the law of physics, cannot pass beyond, or unless we stop developing them, the day is going to come when machines can do everything that we can do for money, cheaper, better, and faster than we can. And to deny this is frankly dangerously complacent. And most people are denying this. Most people who think seriously about this are denying it. That's probably because they're called economists. There's a number of mistakes I think people make thinking about the longer-term future of jobs. One is this idea that it can't happen, and the second is that it'd be a bad thing. A world in which machines do all the jobs could be great. It could be a world in which humans do what we want to do. We play, we explore, we make friends, we have fun, we just lark about. And we could have a second Renaissance. People tend to think that if in a world that had no jobs, there'd be no meaning. What would be the meaning for humans? Most people do not get meaning from their jobs. Many people in this room do, and you're lucky. But study after study shows that about 85% of the workforce does not get meaning from their jobs. It gives structure to their day, but it puts food on the table. That's its main purpose. I think there are three types of people who prove that you really do not need to have a job to have meaning in your life. One is comfortably off retired people, and as you can tell from my age, I know quite a lot of these people, and they do not want a job, thank you very much, they're very happy. The second is aristocrats. In your country as well as mine, we had aristocrats for centuries. Most of them didn't have jobs, and there was no tidal wave of existential despair because they didn't have meaning in their lives. But the third, and the absolutely crucial one, is children. You show me a child who thinks they need a job to have meaning in their life. The problem is money. The problem is resources. How do we share the enormous bounty that the machines will be generating? How do we adapt capitalism to do that? This is a country which, more than most, I do not need to tell you, central planning of the economy and a central organization which determines who gets what, that's probably not a great future. We need somehow to work out how capitalism can adapt to this new world. Some people think that universal basic income is the answer. There's a lot of problems with universal basic income, but the biggest one is the little word in the middle. Basic is not good enough. We need to make sure everybody has a very good standard of living. And I spent quite a lot of time wrestling with this issue when I wrote this book, The Economic Singularity. I think the answer is to do with abundance, is to do with the driving down of the costs of goods and services, so everything is almost free, not quite. But we need to work out the details of this, and we need to work it out before it happens. But even this isn't the really big thing that's coming. The really big thing that's coming is superintelligence. Don't worry too much about the definition of this. It simply means a machine which has more cognitive ability than any human. And actually, because machines can continually be improved, thanks to Moore's law, they will quickly have more cognitive ability than the whole of the human species put together. There are some people who still think this won't happen, or won't happen for centuries, but they're now in a pretty small minority. We don't know when it will happen. I've been thinking about AI for a very long time. I wrote my first article about AI and automation back in 1980. And one thing I've noticed is that Amara's law, which is that we overestimate the impact of technologies in the short term and underestimate it in the long term, that happens over and over again. So when the CEOs of the three big AI labs, Sam Altman at OpenAI and Demis Hassabis at Google DeepMind and Dario Amodeo at Anthropic, when they all say they think, they don't use the word superintelligence, but it's what they mean, when they all say they think it's happening this decade, I think they're probably being over-optimistic, but it may not be more than a decade. And that is no time at all. Again, we need to be thinking about this, and it's a really, really big thing. We're not just creating a better tool, we're creating a new species. We are turning ourselves into chimpanzees. At the moment, there are 500,000 chimpanzees on the planet, there's 9 billion of us, and the chimpanzees have no say whatsoever in their future. And they're quite lucky, they don't know that. When we do the same to ourselves, we will know it. So, what's going to happen? What are the scenarios for superintelligence? It's a bit cheesy, it's a bit cliche to have a 2x2 matrix and a sort of 4 initials, but it's easy to remember for you as well as me. On the y-axis, you've got whether we determine the future or whether machines that determine the future. On the that's the x-axis. On the y-axis, it's whether it's a good outcome or a bad outcome. The bad outcome that we determine is that we stop making AI. And I say this is bad because AI is giving us wonders. It's giving us marvels, and it will give us even more marvels if we learn how to make it friendly. So that wouldn't be a great outcome, but it would certainly not be an utter disaster. The really good outcome that we cause is that we figure out how to control superintelligence. And unfortunately, although there are very smart people, much smarter than me, who are beavering away at this and they think they can do it, I think it's impossible. And I think it's obviously impossible. How can we possibly hope to control, to determine forever what an entity 100 million times smarter than us thinks? I don't think we can do it. So, the machines, I think, are going to determine what happens. And there are some very bad outcomes that are possible. We shouldn't pretend this isn't true. Extinction is possible. But unlike a lot of people, I don't think this is necessarily or even the most likely outcome. There is a very, very positive possible outcome from this, in which the machines think, I need data, and you are 9 billion fascinating little data creators. Some of you have got some serious problems, but I love all your data, you're fascinating, I'm grateful to you for creating me, I want to help you. And I'm going to solve all of your major problems. I'm going to get rid of war, I'm going to get rid of poverty, and you know what? I'm going to get rid of death. What's not to like? I do actually think, as long as we don't stuff things up between here and there, this is the most likely outcome. Is there anything we can do to nudge the outcome from catastrophe to celebration? Now, I'm going to go on a slight digression, because I'm going to introduce a concept which isn't intelligence, it's consciousness. And again, don't get too hung up about the definition of consciousness. It's simply the experience of experiencing. It's what it's like to be you. It's what it's like to see red, or to feel pain, or to feel joy. And there's 3 reasons why you might want to be interested in consciousness. One is, our consciousness is probably the most important thing about us. And if we create conscious machines, we can learn from them about our consciousness. Second reason is, if we create conscious machines and we either don't notice we've done it, or we deny we've done it, we may torture them and kill them over and over again. And obviously, on a whole series of levels, that would be a bad idea. But I've got a controversial suggestion for you, which I'm going to wind up with. If you had the choice for the first superintelligence to be conscious or unconscious, which would you choose? Now, the instinctive reaction, and we heard this in a talk this morning, the instinctive reaction is say, for goodness sake, do not make it conscious. But I think that's a mistake. I think that's confusing consciousness with volition. I think if we make machines conscious, they will know what we're talking about when we say, hey, we can suffer, we can feel joy, please take that seriously. I think the empathy of machines towards us when they are superintelligent may be the most important thing that we ever do. To make that empathy happen may be the most important thing we ever do. And I'm beyond delighted to be part of a startup called Conscium, which is trying to do exactly that, to figure out, can we make machines conscious, and should we make machines conscious? It's an open question at the moment, and I think it's one of the most interesting things to work on. I haven't got time for the so what, but hopefully that's left you with an interesting thought to go away with. Well done for making it to the end, everybody. It's been a fantastic conference. I hope you've enjoyed it. Thank you very much.